So I just kind of had this crazy idea that instead of composting this, I should be making a bioreactor. So what I'm going to do to kind of test this out is I'm going to put kind of the biomass waste into these little containers, and then I'm going to drop them into kind of this plastic container here. And I'm going to set that out here in the sun. So we got kind of plenty of sun. It's got to be like 80 degrees outside right now. So that'll start creating a reaction. As this thing breaks down, it's going to create a couple kinds of fuels. So then I'm going to test for the presence of VOCs. I don't really have a way yet to test for methane or any of these other gases, but I'm going to try to burn it. And we'll see whether or not this fuel is burnable, just to kind of see, you know, whether we're reacting this right. So I've got my AirWare IoT device. That's going to go in here into my bioreactor. That's going to measure temperature, VOCs, you know, CO2, some of the other vital chemicals. Again, it's not going to give me really methane percentage, but I'll know the difference between CO2 and VOC, so we can kind of figure out the difference there. And gonna have to figure out how to deal with kind of the pressure that forms here. So I think what I'm gonna do is I'm gonna create a inflatable bag, probably just be a garbage bag. So these gases will go into there, and I'll seal it, you know, with gaffer tape or something. So we'll see how much we produce. But basically, for now, I'm just gonna use a couple of these little containers. You know, of just solid waste from vegetables. I don't really have any plans right now to use animal proteins or anything fats, but at some point maybe I'll have a plant-based one and an animal-based one, and we'll kind of figure out how much we're doing here. All right, so we have about 460 grams of you know, just pressed greens and fruits. This is kale. It originally came out of a box of kale, which was juiced. That box contained originally about 5 ounces, about 142 grams of kale. It's just cut and washed. We have a medium-sized cucumber here that was juiced. We've got a medium-sized apple, and then we have an orange and a lime. So that's about 460 grams. So I'm going to see if we can't make this into the bioreactor. So just to show, I drilled 4 holes up here. So that's going to hold the gas. And I've got my little IoT device in here. So that's going to be measuring kind of gas. Put that in there. And I'm going to close this just so, you know, not seal it, but I'm worried about kind of juice flowing, so that's why I've got this larger original container for the kale. So, you know, this stuff kind of, if it spills out, it's not going to ruin my IoT device. And I'm just going to seal this bag. I already tested it, so it's going to be deflated when I close it up, and I'm just going to stick it in the sunlight and start measuring this thing. So we'll see what it does. All right, so we got our little makeshift bioreactor back here with an IoT measuring device out in the sun. It's pretty hot today. It's about 88 degrees. It's partially cloudy, but we are getting direct sunlight. So I'm going to be taking a look at the temperature rise in this thing. It's going to get pretty hot. So I would imagine this thing's easily going to exceed 100 degrees inside here. And, you know, I haven't really thought about painting this thing black. It's just a test right now, but I would expect gas to start coming out of this thing, you know, pretty quickly. So we'll have a chance to take a look at what the makeup is based on CO2, VOC, whatever, and then maybe later this evening or so when the sun goes down, maybe I'll be able to start burning some of it. We'll see how long that takes. It could take longer than that, but we'll give it a shot. So just taking a look at these readings from the IoT device, looks like temperature's really risen inside the reactor. Looks like we're hitting some max numbers here. They're not accurate anymore, but at least we know something's going on.